Hello friends, in this video we will learn the working of an OR gate using diode and we will design it on breadboard. Here is the circuit diagram of an OR gate using diode. Here we have to use two diodes. So from this truth table of the OR gate we can see when we apply 0 at terminal A and 0 at terminal B, there will be no current through these diodes, so there will be no current through this resistor, so we will not get output voltage across this resistor. That's why the output is 0 in this case. But if we apply voltage to any one of these two terminals, then we can see from this truth table, suppose we have applied 0 at terminal A, then this diode will not conduct, so there will be no current through this branch. But if we apply 1 at terminal B, then we can see this diode will be in forward state and current will flow through this diode and this current will flow through this resistor also. Suppose I2 current is flowing through this diode, so I2 current will also flow through this diode, so output voltage across this resistor will be V equal to I2 into R. So we will get output in this case. Similarly, if we apply 1 at terminal A, then this diode will conduct, this first diode will conduct and current will flow through this branch, and suppose I1 current will flow, then and 0 at terminal B, then this diode will not conduct, so only I1 current will flow through this resistor, so we will get output I1 into R, so that's why output is 1. And at last, if we apply 1 at terminal A and 1 at terminal B, then both the diode will be in forward bias, so current will flow through these diodes. Suppose I1 current will flow through this diode and I2 current will flow through the second diode, so here we will get I1 plus I2 current in this branch, so I1 plus I2 current, so we will get output I1 plus I2 into R. That's why output is 1. Now we will implement this OR gate on this breadboard. For this project we need a 9-volt battery which is clip and two diodes. Here I am using 1 and 4007 diodes and one 1K resistor. You can use any value, and one LED to observe the output, and to protect this LED we have to use a 100 ohm resistor and some connecting wires and a breadboard. When we observe the diode closely, then we can see there is a silver coated side, that means this side is silver coated, this right side, this one, and the other side is black coated. So this black coated side is positive, that means this terminal is positive terminal and this terminal is negative terminal. So from this figure, this terminal is positive terminal. Here this terminal, that means black coated side, and this terminal is negative terminal, that means this silver coated side. So now we have to insert it on breadboard. Now we have to insert it into the breadboard. So first insert it like this. This side is positive, that means black coated side we have inserted. Then insert the next diode, that is second diode. since these are connected, so we have to insert in the same column here, then the other terminal to other side of the breadboard. Now these two terminals are connected. Now from these terminals we have to connect this 1k resistor. So we will connect this 1k resistor and we have to make it ground. So we will connect it to this row here, this row, so that we will use this row as ground row. Then from this terminal again we have to take out the output. So to take out the output we will use this 100 ohm resistor. Then from the another terminal of this resistor we have to connect this 5 mm LED, the positive terminal of the LED we have to connect, and negative terminal should be grounded, that to the ground row. We will use this row as ground up to this only, because this row and this row is not internally connected. Up to this only internally connected from here to here. Now we have to connect our battery. We will connect the negative terminal of our battery to this row because we have considered this row as ground row, and we will connect this positive terminal of this battery to this row, and we will use this row as VCC. That means from here we will take out the signal 1. Okay, now we have to use two wires, one from this ground row, we are using this black wire, and one from this VCC row. So this wire will carry signal 1 because it is connected to VCC, and this wire will carry signal 0 because it is connected to ground. Now we will observe the output. Here you can see for the first set of input, A is 0, B is 0. Output should be 0. A is 0 means we have to connect it to 0. That means we have considered this one, this terminal is terminal A. So A is 0 and also B is 0. That means we have to connect this also to 0. That means B should be connected to ground. So output is 0. That's why the LED is now off. For the second case, A is 0, it is connected to ground, and in this case B is 1. 1 means we have to connect it to our VCC row. So we can see in this case the LED is on, so that's why we can, the output is, because the output is 1 in this case. Then when A is 1, B is 0. A is 1 means we have to connect terminal A to our VCC row, and B is in this case 0. 0 means we have to connect it to ground. So in this case also output is 1. For the third set, A is 1. A is already 1 because it is connected to VCC. B is 1. We have to connect it to VCC. So in this case also output is 1. So the truth table is verified. So thank you for watching this video. If you like our videos, then please don't forget to subscribe to our channel. You can also buy electronics components, projects, modules, boards, sensors from our official website www.dpvtechnology.com. Thank you.